Right, well, we won't do a customer repair today, we'll do one of my jobs. Somebody mentioned they had a Shira WT622 walkie-talkie. I think they said it was a load of rubbish. But in fact, we've had up to 3 miles out of this type of radio on a good terrain test. That doesn't mean it'll do it on our bad terrain test round here with all the trees between here, even to the top of the hill. And when we say top of the hill, it's in Lincolnshire, it's top of a slight incline. When I first came to Grantham, I was stood on a road which is actually called St Peter's Hill, where the council offices are, and I was outside the post office, and there's kind of several bits to St Peter's Hill. It's a bit complicated, and I said to a passerby, "Excuse me, I'm new here. I need to know where the council offices are on St Peter's Hill." And so she said, "Well, you're on St Peter's Hill, and the council offices are across there." I said, "Oh, where's the hill?" And of course, there's a slight incline. So I can't find the red folder, the "This Is Your Life" folder for this radio. Now, we must have had it 15 years ago, because I scanned this from the photocopy of the instruction book of the original one we had when we did the test in '83. So we have got the instruction book, which is probably more than anybody else has, and so we know how to work it, and we also know some 10 codes. But more importantly, alright, your home 20 is your hometown where you live. So the nice thing about having this is we've got 250 milliwatts output, so it tells us the specification. Now, the one we did the other day, the Harrier WT1, which uses the chassis used in the Harvard 020, the Binatone Ranger 2 and the Alba CBH1, is 200 milliwatts. So it's a similar circuit, it's very similar, but it's a chunkier radio, probably cheaper to make. It's supposed to do 1 microvolt. So it'll be, there's a swine to set up. I have done one before. These are the same as the Amstrad HCB1, which we bought the service manual for, which was one of the cheapest service manuals we bought at £2. Wasn't Sir Alan being kind? And on the service manual it tells us 150 milliwatts minimum, and it says 1 microvolt the same. So which do we believe? Well, anything over 150 milliwatt will be fine. We do have the proper service manual, which we paid good money for. So there we go. So I don't know the history. This will be one we bought on eBay in the last 20 years for this very project. I won't have been in here. Oh, it tells some 10 codes on the back. Oh, we need that. Isn't that handy? It's a pity you need an electron microscope to read it. Okay. So if we had the quarry 1.25 miles on the Harrier WT1, which is the best range we ever had out of that chassis, it'd be nice to have the same out of this. I said Amstrad, the other one's the Harvard 10.4 Convoy. So you've got an altogether bigger board, and so it's more spaced out, so it's actually easy to work on. 2 channels, the same as the other 14 and 30. You've got the battery check. I don't know whether that becomes a call tone. I don't know. Yeah, same rubbish idea of having a speaker as a microphone, which was the thing on cheaper sets at that time. So the usual problem is, how do we get into the far side of the loading coil to actually connect the test gear up. Well, that's handy. It doesn't really tell you. I wonder if Amstrad is still at 1 to 7 Garman Road, Tottenham, London. So T1, L1 is the loading coil. So L1. So we need to be the switch side of L1. We're going to take this board out, aren't we? What's the chances this will be the wrong screw? Another screw there. Thought we'd try and get. I want to get through a handheld at least one a week. I'll tell you what I've bought, and I think it's come today. I've seen it at the Goods Inn, but Mr. Chippy will deal with it. And that is, we had a delivery from our wholesaler, and a few months ago I did a Midland 42 DS. Now we've got a Midland 42, and I might do a super test and do our Midland 42 and the new 42 DS together and see if they work exactly the same. I think that would be a really sensible thing to do. So it kind of does two sets at once, which saves a bit of time, and it's a useful comparison. So we've already got the 42, which I couldn't find last year when we did the, they're not range tests, these are field tests. And we've now got this new one. So I'll tune that up. We've done the tune-up video before, only a few months ago, so we're not going to repeat that, but we'll certainly do a field test, which we weren't really able to do with it being a customer set before, because you don't really want to be going out with them and the potential of dropping them, etc. How do you get these off? Not easy. I don't think they have you do this, you know. I think you tune it up, connect it to through the loading coil, which is really a fake way to do it, but just see how difficult this board is to get out. See what's holding it in. So we wouldn't want to do this with a customer set. There we are, we're out. So we've got a much bigger speaker. But that must be 2.5 inch. So that's, I don't know how that works as I know how it works as a microphone, I don't know how it's going to perform as a microphone. So it is a different thing altogether, but it's a similar circuit. UAL is the make. be fair to this and give it every possible chance, we're going to unsolder the loading coil. You just wouldn't be able to do this, commercially. It'd be far too long to start taking the board out and unsoldering the loading coil. I don't think I'm not unsoldering the right pins. To stop this waggling around, we'll unsolder it too. Come on out. There we are. And you can only get that one way round. It's got 3 pins one side. One's just a locator. It doesn't actually have any function. And what we'll do, we'll solder a thin wire onto that. I think we better solder back all those pins we unsoldered unnecessarily. When I did my church organ building apprenticeship, my organ boss used to have a tin which he kept little blobs of solder in. I found it unbelievable. You know what I reckon we can do? Here's an easy dodge. I wonder if we can get a big blob of solder from there to there, a really big nasty blob which we'll suck off later, just like some screwdriver expert would do. There we go. And now we can use that grey wire to be our output. What a clever move! Negative, that's positive. And then we want the crocodile clip lead, which goes to the one we normally use on the spectrum analyzer. So we'll switch it on. That's noisy, isn't it? So what channel are we going to do this on? Well, I think we need to do it on channel 14. So that is the left hand one. So that's 14, that's 19. And is that squelch? Yeah, squelch on and off. I think those switches are dirty. But they're self-wiping contacts because of the way they work. Okay. So now we'll connect the signal, the test instruments between there and ground. Now that's going to be ground. Is that ground? Anywhere we can clip it to, which is a ground. Oh, you wouldn't believe it. All that soldering, unsoldered, the very lead we wanted to solder. So 2773125. I've realised where they've earthed the crystals is a good point, and that's 10 microvolts. That's better. 3 microvolts. Right, picture in picture. We're on the 3-watt range. If it's doing 150 milliwatts and we're not losing it all in our leads, then it's going to be about there. And that's what it's doing, about 150 milliwatts. So it should be 73125. It's pretty good. It really is pretty good, that. What you'd do normally is you'd look at the other channel as well and try and compromise. So we will look at the other channel. There's the other channel, 2778. That's actually a bit lower. So by turning this one correct, it will also help the other one. They're both in spec, but we want it as close as possible for the best range. So what I'm looking at, I'm hoping the frequency can be adjusted if we look for the transmit crystals. So this is our transmitter. I would think that transformer 10 is going to be adjusting the frequency. Does it tell you to do the frequency? Yes, it does. Adjust T10 for proper channel frequency using a non-metallic tool. They don't give you a layout, they give you this one, which is viewed from the bottom, so is kind of mirror image, upside down, see-through. So 10 8 7 9 10. Yes, you've got the switches there. So it's that coil there. It's T10. See if we can go down, because that's not wanting to. No, it's 73125 we want. It is going to be slightly out. See where our channel 19 is. that's nearly there. That's right at the top, that core. Absolutely at the top. We're going to have to put a spot of glue on that, or it's going to disappear out. I don't know if we've got any wax. So go back to channel 14. So virtually, it's about spot. Oh, I pressed the wrong one. Yeah, it's a little bit out, within tolerance. So that's got it on frequency. So we're back to power. T987 should be more than 200 milliwatts. So there was 10, 9, 8, 7, 9, 8, 7. I don't know whether it's a kind of tar or it's not like you usually get. It smells rubbery as I burn it. So that's no improvement. And did it say that one for maximum output? L1 for maximum. Oh, that's the one we've taken out, isn't it? Yeah. Just see what that does. T6. Okay. So we've not really got the right test set for really low power like this. Under 400 milliwatts, and with all these long leads, it's not really the right tool. So, not quite sure what. With all this, there's a lot. You know, according to this, it's 125 milliwatts. I think it's more than that because we're having the same on other. We could get the Z-Target meter out, but that doesn't read low power well. Yeah, we can't. So we've got it for maximum. That's what it's about. It's on frequency. Let's look at deviation. Wallow. Well, I expect that needs to be about. Let's get the little oscillator out. .4, 1.8 at full whack. Wallow, and just get 2 out of it by bellowing into it. Just imagine having a pair of these when you've got 2 rubbish sets. So I think we're there. So we'll look at receive, which is actually working very well for all these wires. We'll check frequency with the second signal generator as a marker oscillator shortly. So 5, 1 and 2. 5, 1 and 2. Not those two. Oh yeah. It's these 3. So we'll put the cyanide meter on. At least we can get to the speaker on this, which was rather difficult on the Harrier with the confined space. So at the moment we're getting about 10 microvolts for 12 dB cyanide, but again it's long leads. Just making sure we're spot on frequency. So we run through these 3. You know what, I bet one of these is frequency, but they just tell you to twiddle it for maximum, and that's not right. Sure, that's going to be frequency. We'll do this one. I brought it up. And now look at these IF ones. Sorry, I'm showing you, not showing you the right screen. That was the cyanide meter we were supposed to be looking at. We'll look at the oscilloscope for a moment. think these are going to be detector. Yeah. So do that with the cyanide meter instead. About there. There we go. Let's recheck these. So I think that's going to be frequency. So let's just check with the circuit diagram. T5 is going to be have an effect on the frequency, I think. Which is actually going to be that one. So we'll look back into that. So my inkling was wrong. We'll put that back on the speaker. And we'll adjust that red one. Okay, so what we'll now do, I'll take the tone off the signal generator. We'll now get out the cheap Chinese other signal generator to use as a marker oscillator and drop the service wand on the floor. And just set this up for 455. There we are. Now that musical note is the difference between correct frequency and off frequency. So the manual says it's this one for frequency, so we have to null that musical note. It won't quite go on frequency, so we've got still got a musical note. So I'm going to adjust the signal generator and tell you what it's actually on. 73096 instead of 125. So it's slightly, I'm sure it's got a wide enough receiver to be slightly low. So it's slightly low on transmit, slightly low on receive. I don't expect they're the highest quality crystals in the world, and I'm not going to be spending 30 quid each on replacements. So that's the receive setup. Yeah. So put that loading coil back. I should take the power off and we'll remove Mr. Blobby. They actually tell you to take it to the switch, but I've done it my way. I bet you've got more years of experience than the person who wrote the manual. So that's that back in. We need to solder that on first. There's another job you need a powerful soldering iron. Good. So all we should need to do is to check that we've got the maximum output from, I'll take this off, the maximum output from the rod aerial. So with our field strength meter, don't need the patch lead, just put an odd crocodile clip on there, just so that it picks up something. Has that got glare on it? I think it has there. So we'll switch the power back on, switch the radio back on, pull the rod aerial up, so this needs to be in free air, just between the two benches here. We're on bench 2 and it's in the gap between bench 2 and bench 3, and we can see a field strength being, I don't think that's the best picture for you. Hopefully that shows. So now we'll melt the tar or whatever it is in there, and we want maximum field strength. It's actually there. So we've improved this one. Now what I do need to do is I'll get some glue, so we'll take a break, we'll get some glue and or even candle wax, and just stop that core which is right at the end for the frequency. It was down for the receive and it was up for the transmit. So I'll come back to you in a bit. Well, I won't be able to demonstrate the squelch working on this, because even with a foot of aerial poking out, I'm getting SSB interference even beating with the signal generator. I know it's into a dummy load. Let's turn the signal generator off. And of course, SSB isn't permitted on these channels anywhere in the world that I'm aware of, except at sea, but we must have got weird weather conditions. So I don't know if we're going to be able to do a successful on the air test on this, which is a shame. I've just looked, it's 14 and 19, isn't it, the channels on this? They're usually 14 and 30. So what does it say in the instruction book? Yeah, it says 14 and 30. Wow. We've got 14 and 19 on this one. Okay. We must have got early production, because I had an early production Harvard 020 and that came out with 14 and 19. But it's not what the book says. So does the circuit show that? Oh, the circuit's not in there, is it? It's in the service manual. It just says channel A, channel B. (27.89125) it says. Just borrow the Midland manual a moment. 89125 is channel 30, yeah. So we must have got early production. Never mind. Oh, I'll be able to put it on eBay, won't I? I'd be able to put it on as mega rare and start the biddings at £120. What I wanted to know, this was the final thing, is does it transmit a call tone like the Harvard one does? So if I put our little capo set on, testing 1 2, and pull up the aerial and not ruin the SWR. Testing 1 2, testing 1 2 3 4 5. No, it doesn't. It does battery test, and it does nothing when you go into receive. It's transmit side. Squelch does work on this, but it's such today that the weather conditions that we've got a right lift on. So we'll put a battery in that, and we'll do a field test with it with Mr. Chippy. But whether or not that's today because of the weather or not, we'll see. So thank you for watching the servicing of the Shira WT622FM from 1981, where it was a £24.95 wonder.